Hey everyone, this is Brian Shiliak here with my partner Adam Francisco, and we're going to introduce our project. It's called SmartLink. First off, we're going to talk a little bit about our problem statement and why we chose this. Then we're going to give a little bit of background information involving our project. Then we'll talk about what benefits our project can bring, and then our design process and how we're going to go about completing our project. So the problem statement, in the United States, roughly every 13 seconds a home intrusion takes place, and this amounts to over 2.5 million invasions per year. And the more and more we get into smart home devices such as smartphones and smart homes, the less and less we communicate with each other directly. And lastly, we need a more cost-efficient solution. So, there's devices such as ADT, which is pretty costly, and we're hoping to bring that cost down as well as provide additional benefits. So who benefits from this? The first one would be homeowners, as they get a smart home and a security system. The next would be neighborhoods, because the more secure each individual house is, the more secure the neighborhood is as a whole. And lastly, anyone looking to secure their home and enhance communication within the house, because not only is this a security system, but also a communication system that lets housemates talk to each other. And who would be interested in this? Well, 82% of consumers were aware of the Amazon Echo in 2017, and this was up from 47% in 2016. Yet only 17% of homes in the United States had a security system in place. So I think if we combine both security system and a smart home system, a lot of people would be interested in this.
Now we're going to talk about our design process. And we came about this by first researching current smart home designs, and we looked about how we could make them more user-friendly and cost-efficient. And we also looked at how we could add features and capabilities that the current systems weren't providing. So our design requirements break down into 3 different categories for 3 different parts of our project. We have a smart security camera, a smart hub, and mobile app. And so we'll talk about each one of these in greater detail and all of the design requirements for each one. So first, looking at our smart security camera, it has 3 main functions. The first being able to recognize different faces. It will also play pre-recorded messages. And lastly, it will be able to send notifications to a mobile app. So for recognizing different faces, it will be able to tell if a parent or child enters your home. And then it will be able to play pre-recorded messages for specific people. So if your child enters the home and their name is Jamie, the camera will be able to recognize that Jamie entered the home, and it will play any pre-recorded messages for her, such as if the parent left a message that she needs to do the chores. So when she walks in, it will play the message saying, Jamie, you need to do chores, such as washing the dishes. And lastly, it will send a notification to a mobile app. So if you're wondering where your child is late at night and they're out, when they get home, the camera will notify you when they get home, because you'll get a notification through the mobile app. Our second part is the Smart Hub, and it has 3 main requirements. The first is being able to display the smart security camera video feed. It will have personalized widgets and allow the users to leave voice messages. So firstly, it's just going to be able to display the camera feed from the smart camera, and it will have personalized widgets that you can interact with. So such as being able to see your favorite sports teams updates. And lastly, you'll be able to leave voice messages for anyone else in the house. Basically that's how the Smart Hub was able to leave the voice message for Jamie. And so this Smart Hub is going to be placed in a centralized location in the home with a touchscreen, so it's easy to access for everyone. And lastly, we have the mobile app, which has pretty similar requirements to the Smart Hub. It first will be able to display the smart security camera feed, and also have personalized widgets. And lastly, you'll be able to leave voice messages for the Smart Hub, and it will also be able to receive notifications, such as when someone in your house comes home.
The way that we chose to go about our design process means that we can add a variety of additional products and accessories to the SmartLink. One of these, for example, might be a dual authentication Bluetooth and facial recognition door lock. And then also, we can add personal widgets to the Smart Hub in the centralized location. This means that it will always be useful to each individual and they have their own personal space. So even when the Smart Hub's not being used, it could, for example, show weather, or it could show sports scores, or even it could show who's home and who's not. And also, our design allows us to have an expandable number of cameras. So this means that if you have 3 entrances to your house, you can have 3 cameras monitoring each entrance. And also, the Smart Hub can have centralized calendars for the communication aspect, in that you will be able to tell when someone in your house, whether it's a family or friend, has an upcoming event that you should attend, that you should be able to plan for that. So Adam earlier talked about the requirements for the 3 categories. Now I'm going to be talking about how we're going to assess those requirements. And again, it's for the Smart Security Camera, the Smart Hub, and the mobile app. So first we have the Smart Security Camera. And initially, we want to detect faces, which we've already accomplished. And then next, we want to be able to recognize faces with at least 70% accuracy, and then 80 and 90. And 90 being the highest goal, and that we need to recognize faces accurately so we can show them their messages and know if an intruder is coming in versus a housemate. And then we also need to play pre-recorded messages, and that's basically, there's no other assessment metrics for that. We just need to be able to play it when we see the faces. And then we also need to send notifications to the mobile app, and that assessment is just sending the notification successfully to the user. And it all comes back to the recognize different faces function, because that determines the outcome of the other assessments as well. Next, we have the Smart Hub. So the 3 functions for this are to display Smart Security Camera video, display personalized widgets, and allow users to leave voice messages. For the camera feed, our first assessment would be to be able to play clips from when we notice movement or we notice faces. And then secondly, we would like to be able to stream the live video. That would be the ultimate goal of that function. And for the personalized widgets, initially we are going to have some pre-made widgets that you can choose from, such as weather and seeing who's home and not. And later we'd like to be able to add additional widgets that users could download, such as sports scores. And then we also want them to be able to leave voice messages from the hub as well as the mobile app. So the mobile app assessment metrics are nearly the same again. So first, for the camera feed, we'd like them to be able to see clips from when movement was detected. And second, our ultimate goal again would be to stream the live video. And personalized widgets for this as well, such as weather, sports, and adding other downloadable widgets later down the road. And also, we'd like to be able to display and leave voice messages exactly the same as the Smart Hub.
Here we have our morph chart. On the leftmost column is all of the functions, and the selves to the right of that are all of the means. So first we have connectivity, so how all of our devices are going to be connected. Next we have the embedded software, so what programming language we're going to use to program the microcontrollers. Then we have the embedded hardware, which is deciding which microcontroller to use. Next is the mobile app framework, so this is just the mobile app development environment we're going to use to target either Android or iOS devices, or both. Next is the power source, which could be either plugged in or battery operated. And last is the enclosure, so either 3D printing or buying the enclosures. So the ones highlighted in red are the feasible ones. So we have, for connectivity, Wi-Fi, and then Node.js for the programming language, Raspberry Pi for the microcontroller, React Native, which can hit both iOS and Android devices, having the microcontrollers plugged in, and then 3D printing parts, and also buying the parts. Next is our numerical evaluation. To make things easier, over on the left side, we say what category we're talking about when we list off the objectives in the second column. So these are the objectives for the smart security camera. And then over here in these top two rows are the constraints that we might have. So for our numerical evaluation, we had the highest score in this first column, which is for the means is using Wi-Fi Node.js, Raspberry Pi, React Native, having the microcontroller plugged in, and 3D printing the parts. Next, we have our priority checkmark, which is similar to the last slide, but each objective has a priority associated with it, 3 stars being the highest priority. And this same column scored the highest priority of 25. Next, we have the best in class, which is similar to the first one. However, each column is scored between, in this case, 1, 2, or 3, because there's only 3 feasible columns. And the lowest score is actually the best score here, which also happens to be our first column with a score of 12. Next, we have our transparent box diagram. And so this is kind of a high-level overview of our system. So over here we have, if a person is entering the house, we have the smart camera detect this person. And on the smart camera, we both have the Pi camera and speaker, the camera to actually record video, and the speaker to play pre-recorded messages. And this connects to our AWS, which is Amazon Web Services. And this is our cloud infrastructure that we're going to use. And so it will send data such as if a person's detected, play pre-recorded messages from here, and it sends all this data using Wi-Fi. Over here on the right side of our box is the Smart Hub, which has a touchscreen and microphone connected to the microcontroller, which is a Raspberry Pi 3. So the microphone is if you want to leave message for someone to be played from the speaker of the smart camera, and the touchscreen to use your smart widgets or personalized widgets. And this also connects to AWS using Wi-Fi, and it will play over here the camera stream, and it will also get what widgets it needs to use to over here, and then also it will play your recorded messages over to AWS to be transferred over to the smart camera. And AWS also handles sending notifications to the user if someone enters your home. These are just going to be connected using the power source, the Smart Hub, and security camera. So next we have our system architecture slide, and this kind of just expands the AWS box that we had in the last diagram. So in here we can see both the Smart Hub and mobile app and smart camera connecting to AWS over Wi-Fi. And just in here we have API endpoints that these all hit. And from these API endpoints, we use these to determine who's accessing our database. IoT stores different states, and Dynamo will store information such as like the personalized widgets and what should be sent back to the Smart Hub. And also we have IoT devices for also possible third-party integration.
This slide shows how our senior design will think and react to certain inputs. So the first thing it needs to recognize is when a person enters the house, it needs to determine if the person lives there or not. If they don't live there, we need to see if the house owners are home or not. If the house owners are not home, we need to play a pre-recorded message to try to scare off the intruder and update AWS that someone unknown has entered the house. After that, we need to send out notifications to all the house owners with a short video clip of who entered the house and what they look like. If the house owners are home, we need to do the same thing except not play the pre-recorded message to scare away the intruder because they might be friends. If the person does live there, we need to check to see if they have any voice messages left from any of their other housemates. If they do, we need to play the pre-recorded voice message and update AWS that the person is home, as well as send a notification to all housemates that the person has arrived home. For our software security, right now, data is only sent using the home's Wi-Fi network, so we need to notify the user to make sure that the router is using the WPA2 security protocol. All of our sensitive data is stored in AWS, so we don't have to worry about things such as SQL injection because Amazon will handle all that for us. Our APIs will also run through HTTPS protocol and are secured by Amazon endpoints as well. We will also change default Raspberry Pi username and password, as well as give the user an option to update it themselves. This slide is a Gantt chart about how we are going to spend our time. So you can see as time goes on, we'll start working on the project more and more. As of right now, we've only been working on mostly the documentation. And this is the bill of materials. It's our estimated cost of our senior design. Right now, for our prototype, we only have one Pi Zero wireless and camera. So we only have one camera. And for issues and concerns, our first issue is the facial recognition accuracy. Because our facial recognition determines all our other functionality, such as sending voice messages, we need this to be as accurate as possible. Our next issue is the cost of storing so much data, specifically in the cloud. We need to store, this is where we determine whether we want to live stream the actual video or just save specific clips of people entering the house. And our main concern is time. We need time, we need to be able to finish all our functionality as well as make our apps look good, and time is the biggest factor in this. But this has been our presentation, and if you have any questions or concerns now, let us know. Thanks.